In this exercise video, we'll work through a series of exercises that involve lists and tuples. Probably more lists than tuples, but you get the idea. So let's start on exercise 1, lottery number generator. Design a Python program that generates a 7-digit lottery number. The program shall generate 7 random numbers, each in the range 0 through 9, and assign each number to a list. And assign each number to a list. Okay. Then use another loop to display the contents of the list. Finally, ask the user if they would like to generate another set of lottery numbers. All right, let's create a file for this. We'll call it E1 lottery lotter number. I guess I think it's supposed to be a lottery number generator.py. Okay, let me close this, and we will pull it over just a bit. This is exercise 1, lottery number generator. All right, so the program should generate 7. Okay, each in the let's do that first. Start range equals 0. These are some constants. In range equals 9. Assigns each number to another. Then use another. Okay, let's create our main function. And we will call the main function. All right, let's print out the program's purpose, the lottery number generator. That's fairly generic. New line character, get some separation. Program shall generate 7 random numbers, each in the range 0 through 9, and assign each number to a list element. So I'm going to just call this lottery number, and we'll assign it to an empty list, and we'll just append lottery numbers onto them. So a 7-digit lottery. All right, so let's create another constant called lottery digits. Set that equal to 7. So and I'm not actually going to be using the target variable, so I'm just going to use an underscore as a placeholder. No, I shouldn't be using it. For underscore over 4, you can do X if you'd rather, in range sub lottery digits. All right. Let's import the random module. Let's import random.rand as rnd to shorten it. I should be able to do, I don't know if it'll let me or not. Let's do rand. Oh no, it might not, because that's a function. All right, what's next? Oh, okay. So our lottery number, this is our empty list. It's going to hold our, I should call it lottery numbers. Okay, we will append, and we will pass into this our rnd dot rand int and the start range, and we'll also specify the end range. Okay, so that's going to generate a random number. And again, we're not using that, so we can put in an underscore as a placeholder. That looks pretty good. All right, let's just do some testing. Let's print the lottery numbers list just to make sure the program's doing what we expect. 1, 2, 3, 4, 5, 6, 7. Excellent. And there are the correct number of numbers in the list. So this is a empty list object. So all of this is populating list object with values, we'll say. Alright, so now we have another, let's see, use another loop to display the contents of the list thusly. And finally ask, okay, we'll worry about the contents of the list next. For item in lottery numbers, colon, N4. I'm just going to worry about doing the 5 dash and all that stuff. Let's see, if let's see, how do I want to do? I'm probably going to need a counter here. I can't think of another way of doing this without using a counter. So we'll increment counter, but first we'll do if counter is equal to 0, which all that means is that it's the first value. We could just create a string here and just build it, or we could print it all out at once. It doesn't really matter which way we go. I think I'll just print it out versus building a string. Let's print item by itself with no ending character and a separator. Or do I want to just do that myself? I think I'll just do it myself. And I'll show you what I mean by that. Otherwise, we'll print this, and we will concatenate. I guess separator will probably need to be an empty string as well, just to make sure there's no extraneous spaces. So we will, well, I suppose I could just do it this way. That would be fine. No need for concatenation. Alright, so and if, and let's put an equal sign after sep. Okay, then we increment the counter. What else do I need to do? I need to do an empty print statement so that it moves down to the next line. Oh, no I don't, not there. I'll need to do it after the for loop. So we'll do an empty print state to get the new line character from it to go to the next line. Alright. I think that's going to be fine. If I want the lottery numbers part at the beginning, then I'd have to do it before the loop. So print the word lottery numbers colon we'll go ahead and do a space because I'll do separator equals nothing, and or rather empty string, and end also equals empty string to get it on the same line. Alright, if we have done this correctly, and I think we have, then this should print out lottery number generator and then lottery numbers 5 digits, but it won't ask if we want to do another set. Is there an extra? Oh, there's an extra space there. And I'm still printing out the don't need that. Alright, let's try this again. Lottery numbers 1, 2, 3, 4, 5, 6, 7. Looks good. Let's try it again just to make sure there's different values. And there are. Alright, that all looks good. Alright. We could now, or rather now we need to ask them if they want to repeat. Alright, so after this we will what should we call this? I'm just going to call it run again for lack of something better. And we'll set that to the input of generate another set of lottery numbers question y-n or y/n colon space, and we will use the lower function to force whatever they enter into lowercase, and we'll do while run again does not equal lowercase y or does not equal lowercase n. Oh, sorry, while run again does not equal lowercase n we could do, we'll tell them please enter either y, oops, we're gonna have to do some oh, what am I doing wrong? Do I have it the wrong way? Let's do it. Try that again. Okay. \w \w. I'm not sure if I had it the wrong way or what. Oh, yeah, I'm not sure what the problem was there. So there's my y or and then n and period. Please enter either y. Yeah, that'll be enough, and then we'll just ask them to enter the lottery number again. Okay, once that's validated, we can put probably, I'm going to take the new line character out from there, and we'll print there. So we will say while we will have to do while run again equals y, while run again is equal to y, and then just have to tab all this in so that it's under the while loop. I think that's it. We'll have to See if I've got any bugs. I think this will do it. New line character. Where do I need to put you? Well, I could just put a new line inside that print. Let's do N to stop it. Oh. N did not stop it. Okay. Alright, so I Control C to kill it. I probably have this backwards. So usually when I have that happens, it means I've got my logic on my while loop backwards. So N, good. N terminates the program like we'd expect. Y, whether it's generates another set of random numbers. Let's do Y again. Good, that all looks good. And if I try to put in something other than Y, please enter either Y or N. So let's do another Y. That looks good. And N to close. All right. And there we go. This is exercise 1, lottery number generator. And it generates a 7-digit lottery number. But, of course, the cool thing is, if I wanted it to generate more than that, all I'd have to do is modify the lottery digits constant, and now it does 10 numbers. Because I wrote my program in such a way that it wasn't tightly coupled with 7 digits, so it works based on the however many lottery digits I define. Alright, and just so that we're all on the same page, the reason I did it this way was so that I didn't have an extra dash at the end. So I tested for the first element and just entered it, and then every other element I did a dash before it, and then outputted the item so that I didn't get an extra dash at the end. Alright, I'm going to close this program and move on to the next. E2, it's a program that I almost always have my students do in any class, and that is to create a password generator. It's a good exercise. Let's go ahead and create our main function. Okay, so exercise 2, password generator. Write a Python program that generates passwords based on a user-defined length. Passwords shall contain numbers, lowercase letters, and special characters. When the program executes, ask the user how many characters the password must contain and how many passwords of that length the program shall generate. Now, we are discussing lists and tuples. Should we do a tuple instead of a list on this one? I guess we could, unless I run into problems, but I shouldn't. So let's do a tuple. Now, you can't really create constants in Python apart from doing uppercase names on your constant variable names. But we will assume that these are constants. And I'm going to do characters. Oh. Actually, I said tuples. I changed my mind. I'm going to do a string, which is another type of sequence. I could do, just so you know, I could do 0, 1, 2, and so forth. But that's going to be a lot of typing. Whereas if I use another sequence, which is of course a string, then I could just do 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and it's going to be a whole lot easier versus doing all that extra typing. So we'll do numbers. Let's do lowercase characters. We'll set that equal to A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. Let me make sure that's all of them. I'm going to just count them real quick. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Good. I'm going to be a little lazy here and do uppercase characters is going to equal, and these are technically in most programming languages would not be considered constants, lowercase characters dot upper, and then special characters equals. I'm going to change this from numbers just to make it match all the others to numeric characters. And let's just do cars instead of characters. We'll do an abbreviation so that it's not so big. Alright. Oops. No tab there. And these are going to be, I think it's just the top row. Pound symbol or octothorpe. Yeah, it's just the first 5 characters in the top row. So those are my quasi-constants, even though technically I shouldn't be doing it like this because lowercase is constant, but in Python there is no, well, there is one way by creating, returning them in a function, but this will be our way. Alright, so I've got all that together, and I'll show you why I did them. I could have done them all in one, but I'm just going to do them separately, and we'll see why I do that in just a moment. So program's purpose, we'll just print out the password generator and then a new line character. All right, and oh, I gotta change this to lower cars since I've changed the name. Lowercase cars. All right, so let's ask the user for, I'll just say password length, and we will set that equal to the input of length. Oh, this is a string, length of password colon space. Let's do some validation here. While, let's do password length dot is digit equals false, or is equal to false, I should say, and while. So this is going to, because I'm looking for a non-float number or an integer only, this will work for us. We will tell the user a password length must be 1 or more characters long. I'm not sure if that's the best way of saying that, but it'll work. Notice that I have not converted this to integer yet. I'll wait until this is validated and then right below it, because if it gets to this point, it should be able to be converted to an integer. Let's do int password length. Notice that I'm not using a try statement here. I could, But the only reason why I'm not is because the isDigit function is going to take care of everything. Let's demonstrate this. Oh, that's odd. Okay, let's cancel that. And I'm on password generator now. Let's try that again. There we go. Okay, so if I do, for instance, -5, that's not going to be acceptable. It has to be a non-negative integer. Oh, I bet 0 will work though. I bet 0 will work. It does. So while password length isDigit equals false and password, we'll have to convert it to an integer on the fly here, and that's going to be okay because this should catch all characters, data, and the like. So password length is less than or equal to 0. That way it's always got to be one character or at least. Now we'll have to see if I've got that backwards. Let's do 0. Okay, looks like I've got it backwards. There we go. A password length must be 1 or more characters. So 0 won't work, -5 won't work, character data won't work. I don't know why I used and. Let's do something else. But if I enter 1 or more, it does work. Let's do something very similar for the number of passwords that are output. And I'm actually just going to copy and paste this because I don't like reinventing the wheel once I've invented the wheel. So this is going to be, instead of password length, this is going to be number of passwords, and we will ask them for number of passwords, while number of passwords isDigit equals false. And again, we will make sure they don't enter anything 0 or under. Well, specifically 0s for this because the under would be caught by the number of passwords isDigit. Let's change password length to number of passwords. Change this to, instead of length of passwords, number of passwords. And we'll change down here, number of passwords equals the integer conversion of number of passwords. So I just need to change what I need to tell them. Oh, how do I want to word this? Enter a value greater than, oh, I'm not sure, equal to 1. I'm not sure if that's the best way of saying this, but it will get me past this and tell the user enough information. I'm going to do 5 for the length, and then number of passwords, we'll do all our tests here. Let's do 0. That doesn't work. Enter a value greater than or equal to 1. Let's do -5. We'll do -1 just to test it too. Let's do string data, and then do 5 to make sure that it works properly. All right. Now that I have all of that data, I could create a function here, and I think it might be, well, yeah, let's do a function. Let's call our function def, for define, of course, generate password, and because it generates multiple things, I'm only going to have it generate one password, and so I'm only going to pass the number of characters, or the password length. Because usually a function does one thing, and I could make it return a two-dimensional list, but as in the lecture video, I'll promise that I would not have you guys do that. So we will make it generate one password, and then in our main program loop the number of times that the user specified, or rather the number of passwords. We'll loop that many times, but we'll only generate one password at a time, and then call the function every time we need to generate a password. And hopefully this will make sense as we move forward. Let's do length of password and a second password characters. And the only reason why I'm doing that is to make our program not so tightly coupled with the constants. So I'll pass the constants from the main function here so that I don't have to up there. And this is gonna, let's call it password cars list, which is what it actually is going to be. All right. So this is going to be a value returning function. And how do I want to do this? All right, let's do let's do let's create a variable called password and set it at equal. What's it supposed to do again? Let me ask the users how many characters password, and then how many passwords of that length the program will generate. So it doesn't actually say anything about using lists. Well, technically, these are not lists; these are sequences. So I'm just going to call it password characters. I could call it potential or possible password characters, or something like that. And we will eventually return password. All right. Do I need to know which character? Probably not. Okay. Range, sub, and what did I call it? Password length? Password length. I'm sorry, forward underscore in range password length. End 4. All right. So I want to concatenate onto password. Now, strings are immutable. We'll learn this next week, but strings are immutable, which means they cannot be changed. However, if I copy over a variable, a string variable, it will get a new memory location, so it gets around the immutable part. I want to take my password characters and randomly get a one item from it. So I'm going to do password characters RND, because that's what I aliased my stuff as, random int. I did do that, didn't I? Did I do that one, this one? Oh, I haven't created that yet. Let's do import random as R&D, so I can aliased it so that I only have to call it by R&D. rnd.randomInt, and we'll pass into it random int. It's not picking that up. rnd.ran. There we go. Does it have to have random int? Do I have to specify a start and end? Looks like I do. So let's specify 0 and -1, and that should get the last character. Oh, no, that won't. That's going to return a character, not the index. So let's do length, or len function, password characters, password cars, rather, -1. And I have to do -1 because it's always one less, because counting starts at 0. Length returns the actual number, but indexing in a list or a sequence starts at 0. I think that will work for me. So let's talk about what's happening here. I am concatenating onto my empty password. Let's assume this is the first iteration. The one character that I'm randomly choosing. So this could be something like password plus equal password cars sub 50, for instance, and whatever that value returns. And that's what's happening here, assuming that it works properly. Okay, so that builds the string, and then we return the number of passwords, rather the entirely created password. So we're going to have to make sure that we do this properly. So this is going to be my generate. This is going to be where I generate all my passwords. Alright, let's do for underscore in range sub number of passwords. So this is going to generate the number of passwords based on how many the user wants to generate. So what we got to do here is print generate password, and we'll pass in the length of the password, which is just password length that we called up there, comma, and a concatenated sequence, a concatenated string of all the potential password characters. So what I'm going to do is up here, right before I do this, I'm going to create a variable called password cars and set that equal to numeric characters plus lowercase characters plus uppercase characters plus special characters. That's going to concatenate all of my various character sets together. Concatenate all character sets together so that I can pass that into my function, and I only have to do it once, or I only have to put them all together once. So that this is going to return the password that I generated here, up here. Alright, this all looks good. I'm very happy so far. And I actually think, apart from doing a new line character here, or a print, an empty print, so I get some separation, I think this is it. Let's see if I've made any mistakes. Let's do a length password of 5 and number of passwords also equal to 5. Alright, that all looks good. Notice that I've got a digit I've got a lowercase character, I've got uppercase characters. I do not see any special characters, but there's only 5 of them. So I kind of have to hit the lottery to, I just did a lottery program to get those, and they're at the end. So let's run it a couple more times to see if we can get some of those to appear. Okay, still no special characters, so let's do 10 and 10 so that I've got more shots at it. There we go. There's an @ symbol, an X, an exclamation point. I got all kinds of them. Let's count how many characters we have here. 1, 2, 3, 4, 5, 6, 8, 9, 10. Excellent. So it looks like it is performing as we specified it to do. Perfect. And we used a value returning function to generate our passwords for us, and a for loop inside our main program to generate the number of passwords, where we call the generate password every time we want to generate a new password, and pass into it the number of characters that the password has to be and the potential characters that we have to choose from. Anytime you put special characters, such as spaces or periods or exclamation points, what have you, in your password, the difficulty of breaking that password becomes exponential. So be sure to make sure you put special characters in your password. Over 8 characters with special characters, and you will have a very strong password. Typically, we try to encourage people these days to not focus on passwords, but actually to focus on pass phrases, like obscure song lyrics, more of a sentence versus a word, and those would take our current technology thousands and thousands and thousands of years to break if we tried to brute force it. So there is exercise number, and I can't get all of it on the screen, exercise number 2. Alright, the last program is using a pie chart, but the cool thing here is that we will be reading some stuff from a file, and that should be very useful for this lab, so I definitely want to do this one for you. I'm going to close this one and open a new, or create a new file. We'll call it E3 expense pie chart. Oh, I forgot the PY. Rename .py. Alright, so this is going to be exercise 3 expense pie chart. I'm going to actually close my workspace, or remove the folder from the workspace, and then add it back, but I'm only going to add in chapter 7 so that I don't run into the issues with visuals. Wait a second. Oh. Let me close this. Was I not saving these in the right place? Okay, let's do Python exercises. Oh, I wasn't. I'm going to drag and drop those into 7. Chapter 7. Okay, so now I can close it. Remove folder. And then I'll add only chapter 7. Add, so that I don't have any issues reading from the file. Create a text file that contains your expenses for last month in the following categories. There's several ways we can do this. Some are better than others. I'm going to, did I say what to call this file? I'll just call it expenses let's do expenses. Let's do expense costs.txt, and I'm going to create another one called expense expense labels.txt. And what we'll do here, instead of doing a two-dimensional list, we will do two separate lists that have the same number of elements and correspond to each other. So let's do labels first. Let's do rent, electric, gasoline, food, miscellaneous, savings. All right, and I'm not sure what to put. So if I did rent first, let's split this so I can see. So rent, let's say rent, let's say when I was in grad school, my rent all together, of course I split it with my roommate, it was something like 445 or something. So I'm just gonna do 450. Electric, we had really cheap electric because I think the most expensive it ever got was like $80, something around 80. Gasoline, for some reason I'm thinking only in grad school. We didn't have far to drive, so gasoline wasn't really a problem. Let's do, this is monthly. Yeah, these are monthly expenses. Let's do, I don't know, I'm just going to make some up. 62.30, that's not 30, 38. Just some number. Food, oh gosh. I did eat out a lot in grad school. Let's budget $100. Miscellaneous, we'll say $75. And savings, I did try to put a lot in savings, but I was in grad school. Let's put $150 each month in savings. Now, this isn't very accurate, truth be told, because I only got paid $5,100 a semester, so some of the money's going somewhere, but it is per month, so I'd say that that's fairly accurate. Alright, so these are my labels and these are my costs, and close this, and we'll close this and go back over here. Oh, sorry, I didn't want to close the, we'll leave that open. Alright, so you have to install the Matplotlib library. It is not part of the standard library. So you have to install it externally. Take a look at the lecture slides for the command to install Matplotlib. I've actually already installed it, so if you want to learn how to install it, take a look at either the lecture slides or the lecture video. Let's create the main method, or the main function, depending on which school you're in. End main, or just end method. I usually don't specify which method it is. And we'll call the main method. Alright. I have to import Mat, I'll have to see if I can remember this, matplotlib.py plot, I think it is, as PLT, and I'm not sure if that's right. I might have to look this up. It's not complaining about it yet, so yay. Now alias that as PLT. Let's see if I got PLT dot. Oh yeah, it looks like I've got it right. I need to read both of my, okay. Let's do PLT dot, I think, oh, I don't remember. Let me take a look at my lists and tuples. Let me take a look at the lecture slides. I think I just used PLT and title. It's a function. I don't think I have to create. What I'm curious about is if I have to create an object. I don't remember. I do not have to create an object. All right, so let's do. Oops, get this back up. Title, and we'll call it. Looks like we're calling it monthly expenses. And we will plt.show to display it. And if I run this, it probably should just work. It's just not going to have only monthly expenses at the top. Yeah, that's all it shows. I'm going to create a value returning function called read file. It is going to accept a file name, and it will return a list of whatever's in the file. So let's do end method. So file object equals open. We're going to open the file name that's passed into this function for reading. If we open it, we should close it. Might as well do that so we don't forget. For each line in file object, let's create a list object. I'm just going to call it what should I call it? Items in file, because I want to make sure that no one's confused. Items in file. Let's do items in file dot append, and we will append onto it a new each line, but I want to make sure that I right strip each new line character, because I don't want there to be a new line character, because there is one at the end of each line when it reads it in, but I don't want it to be in my list. Okay, let's do, just to be sure, if line is equal to an empty string, or rather if line is not equal to an empty string, just to make sure. It probably wouldn't matter, but let's just be cautious. And then we will return the items in file. We could call it items list instead. Let's do items list. Items list and items list, because it is a list. Alright, we do need to do try. So we're going to try to do all that stuff. Except file not file exists, file not found. I can't remember the difference between these. We'll do file not found. And if we have that exception, we will output immediately I'm just going to say the specified file does not exist, colon, and then we'll print out the name of the file. Alright, so we'll try that, else we will close and return. Remember, else only fires or executes if there are no errors. this is my in try. So if there is a problem, we probably should exit. Now keep in mind that's going to throw an exception because we've exited prematurely, but we probably should exit if there's a problem there, because the chart's not going to output correctly. Alright, so I think we've got this right. Let's do we'll go above this. Let's do what did I call it? Expense costs, and we'll set that equal to read file, where we pass into it. I probably should create a constant for this. Expense costs file equals expense cost.txt, and we will do expense labels file and specify that file. So we will read expense cost file, and then for expense labels, labels, we'll read in expense labels file. Labels. Alright. So plt dot pi, and we'll first pass in the cost label, the expense cost list, and then we'll specify labels equals expense labels. I think that's it. This is going to be, just so you know, quite useful for the lab. Hint. There we go. Because these two files are congruent, in other words, the first value is associated to the rent, the second value is associated to electric, and so forth, this works. And this is called something when you have two lists that symmetrical lists. I forget what it's called. I can't think of what it's called. It has a special name when you use two lists that they're separate, but they work with each other, and they have the proper order. I'm not rightly sure what I used to. Looks like rent on this one was is there not as much, or others were larger. But there you go. That's reading from a file to get values, two files, truth be told, to get values for our chart. Let me put some separation between my import and my constants. You don't have to actually do a chart on this lab. I just think that the fact that you can do charts so easily in Python is really cool. But this part where you have to read a file, your 8-ball responses.txt file, something like this is going to be very valuable, because that's pretty much the I think I have you call it something different, but this will work very similar to how I've done this, which is why functions are so important. You can write them once and then reuse them later without having to reinvent them. Alright, that's the 3 exercises I had on cue for this week. Next week we will talk about some string manipulation and some various methods similarly to how we use things with lists and tuples, because a string is just another type of sequence. And it'll be fairly easy because you can transfer everything that you've learned from this week to next week. As always, if you have questions, feel free to shoot me an email. Apart from that, I'm going to bring this video to an end. I hope you have a fantastic rest of the day.